So we will be dealing a lot with solutions, and one aspect of our solutions is its concentration. You want to be able to figure out how much solute is in that solution. And then depending on whether that solution is a mixture of solids or mixtures of solid and liquid or mixtures of liquid, you have different ways of citing that concentration, of saying what that concentration is. And so we'll learn about different units of concentration in this section. Okay, so for example, if I have a solid mixed within a solid and I want to know what is the percent of the solute, I might want to use mass percentage. Or if I have a mixture of liquids, I might want to use percentage concentration in volume instead. And then in some fields, it is more convenient to write the ratio between the mass of a solute versus the volume of the solution. We can see that as mass per volume percentage. And lastly, in chemistry we have a new unit that I would like to introduce to you. It's called molarity, and that's moles, right? Moles, that's a very chemistry thing. Moles over liter of a solution. So we'll go over each one of these one by one. And so the first concentration unit I want to talk about is percent by mass. The definition of this concentration is that you have the mass of the solute divided by the mass of the solution times 100%. So let's do an example. The example here reads, when water is added to 8 grams of KCl to form 50 grams of KCl solution, what is the mass percent? Okay, so again, we need to know what is the mass of the solute versus the mass of the solution. From the problem, we saw that the mass of the solute, which is KCl, is 8.00 grams. So in this case, we already know that the mass of the solution together is 50 grams. So we can just divide this by 50 grams of KCl solution. SOLN is my abbreviation for solution. Multiply this by 100. So all of these units, because it's a percentage, it's a ratio, they will be insignificant. They just cancels out. So all you have left is to worry about is the numbers. 8 divided by 50. What does that turn out to be? 3 sig figs, 1, 2, 3. Right? So that's 16.0 times 100, 16%. So we can write that as 16.0% KCl mass over mass solution. Okay, so not to be tricky, but that was a simple case. What if I stated the problem differently? What if I said that you have 8 grams of KCl and you add 50 grams of water? Would you solve that problem in the same manner? So the trick here is to go back into your definition. The definition of percent by mass is that mass of a solute divided by mass of the solution. So if you plug it in, is the mass of a solute still 8 grams? It is still 8 grams, right? 8.00 grams of KCl. But is the mass of solution 50 grams? The answer would be no, because water is your solvent, not your solution. What is the solution? The solution is composed of your solute plus your solvent, right? So you can't just put simply 50 there. You have to add these two numbers together. The solute plus the solvent. So the solution is 58.00 grams solution. So instead of 50 here, it's 58. So if we were to do this problem, that's 8 divided by 58 times 100. So if that was a problem, the answer is no longer 16, it's actually 13.8. Okay, so those are two different ways for you to computate the percentage of solution mass by mass. So let's do a checkpoint now then. The checkpoint reads, how many grams of KCl are needed to prepare 150 grams of a 7.25% mass over mass KCl solution? So in this problem, what is given to us? We know that we have the percentage, and we know we have the mass of the solution, and we need to know the mass of the solute. Remember that the concentration can be written as a conversion factor. So for example, if I'm given that the percentage is 7.25% mass over mass, how do I write that as a conversion factor? You can write that as 7.25. Remember, it's percent, right? 7.25 per, what does cent mean? Cent means 100, so that's per 100 something. Going back to the definition, what was on the top and what was on the bottom? The definition was mass of the solute, right? So in this case, I can use grams, and the solute was grams of KCl over grams of your solution. So that is my conversion factor. So let's start with our given. Our given is that we know we need to start out with 150 grams of solution. We need to use our percentage as a conversion factor. Grams of solution, so this is okay to stay in the bottom. And this number is on the top. Okay? When we do this math, we see that the grams of solution and grams of solution cancels out, giving us 10.9. What's our unit? This is the only unit that's left, so that's 10.9 grams of KCl. A note about sig figs here. We have 3 sig figs over here. We have 3 sig figs here. This is a percent, is a ratio, so that 100 doesn't have any significant figures, so we can ignore that. So that's why our answer has 3 sig figs. Now what does this number mean? 10.9 grams KCl. That means that if I took out 150 grams of that solution, 10.9 grams of that solution is KCl, the mass of the solute. Alright, let's do this again, now using a different concentration unit. This time we're going to do percent by volume. Again, let's start out with the definition. The percent by volume by definition means any volume of the solute divided by the volume of the solution times 100%. Okay, so let's check this out with our example. So it says in a 59.00 milliliters solution of vanilla extract, 20.65 milliliters of it is alcohol. What is the percent alcohol by volume? Okay, so we want to know what the percent of the solute is. In this case, the solute is alcohol, and the solution is the entire thing, the vanilla extract. Okay, so in this case, to calculate the percentage, you would say, what is my volume of solute? That is the alcohol, so that's 20.65 ml of alcohol divided by 59 is your total volume of your vanilla extract. I'm just going to rewrite as vanilla extract. Multiply that by 100. As long as your units are the same, you're good. If this is milliliters and this is liters, it won't work. As long as the unit is the same. So it turns out then, if you do this math, it's 35.00% alcohol, volume by volume. So the third concentration unit that we will learn is called percent solution. And this one is a little bit tricky because you're not only having mass over mass or volume over volume, but you're having a mix between the two. It's a concentration is the ratio between mass of a solute over volume of the solution. And the mass and the volume is quite specific. In the past, when you would talk about percent by mass, you can use any mass you want as long as the two masses are the same, right? Grams over grams, grams of solute over grams of solution, or kilograms of solute over kilograms of solution. Or in percent by volume, you have milliliters of solute over milliliters of solution, or liters of solute over liters of solution. It doesn't matter as long as those two units are the same. In percent solution, it does matter what the unit is, and you have to use the exact unit. And the unit that we're concerned with is, for mass is grams, for volume is milliliters. Okay, so let's take a look. By definition, it is mass of the solute in terms of grams divided by volume of solution in terms of milliliters. Again, multiply by 100%. So let's check this out with an example. In the lab, a student dissolved 5 grams of sodium chloride with enough water to have 250 ml sodium chloride solution. What is the mass per volume percentage? Okay, so let's apply this definition to find out the concentration unit. What is the mass of our solute? Our mass of our solute is 5.0 grams of sodium chloride. Right? Divided by, what is the volume of our solution? Is 250 ml of sodium chloride solution. Okay, notice I use grams and milliliters, so that's good. Multiply by 100%. Doing that math, I get 37% mass over volume NaCl. So now let's do a checkpoint. A patient needs 100 grams of glucose. The number of liters of a 5.0% mass over volume glucose solution that must be given is what? Okay? So let's write out all the things that we know.
So,
A patient needs 100 grams of glucose.
and
The concentration is 5.0 mass over volume glucose solution. What we need to find out is the volume in terms of liters. Right, so how will we set out this? How would we set up this equation? Our given is that we need to find the volume in a 5% solution that contains 100 grams of glucose. So that's what we're going to start out with. Grams of glucose. Okay, so how do we convert grams of glucose to volume? Well, this is our conversion factor, right? So how do we write this as a conversion factor? 5% is 5.0 grams glucose. Again, I know how to write that because the definition is mass of the solute in grams divided by volume in milliliters. So that's why I know it's 5.0 grams. Percent. Again, think of how percent is translated. Per means line, cent means 100. So per 100, what's my unit? Specifically here, the volume must be in milliliters of solution. So it is very important for you to see this number and be able to write this conversion factor. Plugging in this conversion factor, what do I get? We can't plug it in as is because if we put in 100 ml solution out here, it doesn't cancel out. So we have to do the inverse of this. So that's 5.0 grams of glucose per 100 ml solution. So if you do that, the grams of glucose goes away, giving you your unit of ml solution. That's 2,000 milliliters. But again, we want our answers in liters, so that's 2.0 liters. Now, why is it 2 sig figs? Going back here, there's 1, 2, 3, 4 sig figs, and 1, 2 sig figs. So our answer finally has 2 significant figures. Our last unit for concentration is molarity, and this is the one that is important in chemistry. You will see this kind of unit in the lab. So molarity, abbreviated as capital M. The definition of molarity is moles of solute over volume of solution, specifically in liters. Okay, again, it's just a ratio of the solute versus the solution, but particularly for molarity, we're talking about moles, not grams or kilograms, but moles over liters of the solution. Not milliliters, but liters. So you have to first convert everything to liters. Okay? So for example, if I wanted to make a solution by dissolving 58.4 grams of sodium chloride in 1.0 liters of solution, what is my molarity? Okay, so to calculate the molarity of the solution, can I just put in 58.4 grams? No, right? Because the mole is what is needed. So I have to first convert this into moles. So how do I convert grams into moles? Using the molar mass. Right? So 58.4 grams of NaCl. It turns out I conveniently chose a very round number here. It turns out that the molar mass of NaCl is 58.4 grams per mole. Okay, so grams and grams will cancel each other out. Grams goes away, giving you 1 mole. So it's actually just 1 mole, right? Okay, so to get the molarity, I would put that is 1.00 mol of NaCl divided by the volume in the solution. What's my volume? 1.0. Okay, so 1 divided by 1 is 1. So the molarity of this concentration is 1.0 because 1, 2, 3, 1, 2 sig figs, so your answer has 2 sig figs. Moles per liter, right? Moles per liter. Or I can just simply say 1.0 capital M. So those are the 4 units of concentration that you will be responsible for in this class.